Okay, so now we're going to find the distance between two lines, but we're actually going to cheat and we're going to find the distance between a point on one of the lines and the line, the opposite line. So it'll be exactly like the question we just did. But the unique part about this is we're going to, before you go off and figure out what the distance between these two lines are, you better make sure that they're not the same line or that they don't intersect. So before you do that, the first thing you're going to do is just compare the direction vectors because you want to find out if they're parallel or not. So in this one, what's the direction vector for L1? Very nice. And D2, John? Good. So right away, are these parallel? Yes. All right. So because they're parallel, then they are either going to be running alongside each other so that we can actually find the distance, or they're going to be the same line. So we got to make sure that they're not the same line, because if they're the same line, there's no distance and the question's over. So how would we find out if they're the same line or not? Very nice. Aaron tells me I'm going to take a point from this one, which would be 6, -3, 0. And we're going to test that one on the other one. So we're going to put it on, is it on L2? Because if the point P1 is on L2, then it turns out we have the same line. So we're going to do a quick little test. We're going to plug in 6 equals 1 minus t. And we'll get, that's negative, or that'd be, yeah, -5 equals t. And then we're going to take the y here and plug it in here. So this would be -3 equals -2 plus 2t. It's -1 equals 2t, so -1/2 equals t. So right away you see you get different values for t, which means this point is not on the line, which means these must be distinct. We do know that they're parallel and they're distinct. If at this point you'd figured out that t was the same, then it turns out that point 1 is on line 2, then you know they're parallel and they're the same line, which means the distance would be 0 and you'd be done. If before this you even found out that they're not parallel, you'd have to see if they're skew and then find the distance between them. If they're not skew and they're not parallel, that means they're intersection at a point, and so your distance is 0. So the question would be done at that stage. But this one, since we're doing another example, turns out that they are parallel, they are distinct, so they're two lines following along each other, and we'll be able to find the distance between them. So we're going to draw the same picture that we drew for the other ones, except we're going to draw, we'll draw this line right here, and this line right here. Make sure they look parallel. I'll call this one L1, and I'll call this one L2. And like we said, what we're going to do, instead of finding the distance between the two lines, we're actually just going to take a point on line 1 and find the distance between that point and the blue line. So can someone scream out a point that's on line 1? Very nice. I'm going to cheat and call it A again, just so it has the same notation as the one before. Now I'm going to find the distance between that point and the line. And it'll be just like the question we just did. So there's that perpendicular distance that I'll need. There's the right triangle. I need a point on L2. So Dakota, what's the point on L2? Man, you guys are really good. You're really following and understanding this really well. So it is, sorry, what'd you say, Dakota? Excellent. So now that we have P, we'll draw the side AP. And we'll have the exact same triangle that we had last question. There's AP, there's A. We'll use the Pythagorean theorem to get the red line. Okay. I know in a second I'm going to need the direction vector for L2. And someone yell out the direction vector of L2. Very nice. Okay, so now we go off and find the three sides. We'll start by finding the magnitude of AP. So Emma, what's AP? Very nice. You guys are doing this really quickly. -5. Sorry, what did you say? -5? Everyone agree? And we got that by doing P minus A, P minus A, P minus A. And then, of course, we're going to go off and find the magnitude of that. So it's the square root of the squares. So it'll be the square root of 35. Good. Now we're going to go off and find A. And remember, there's a big long formula that we have to have memorized. And what's that big long formula for A?
AP dot D over the magnitude of D.
Very good, Isaac. Nice job. It's very impressive that he's memorized it that quickly. So that's good. So now we're just going to plug in the numbers. So AP is what we just figured out that Emma told us was -5, 1, and -3 dot D, which is the direction vector here of D2. So it's -1, 2, -5. All over the magnitude of D, which is going to be the square root of the squares. So 1 squared is 1, plus 4, plus 25. Continuing on here. Multiply, and we're going to get 5 plus 2 plus 15 all over the square root of 30. So it'll be 22 over root 30. So now we've figured out what AP was. We figured out what AP was. We figured out what A is. We now got to use Pythagorean theorem to go from there. So now we're just going to use Pythagorean theorem to finish this off. We know that AP squared is the hypotenuse. It's going to be A squared plus X squared. Remember, X is this part up here. And so Pythagorean theorem will go there. We know that this is root 35 squared equals A squared. Well, we just figured out that A was 22 over root 30 squared plus X squared. So now we square everything and we're going to get 35, root 35 squared is just 35. 22 squared is? Sorry? 484, very good. You do that off the top of your head? Good. We're going to do 335 minus 484 over 30. This is where you're going to go to your calculator, but these students that I have sitting in front of me are very, very smart that they can do this off the top of my head. And finally, they'll get an answer of? 4.34. Wow, that's awesome. This is definitely the smartest class I've ever taught. And there you go. We have our distance between two lines.